Here we have a problem on derivative. That is, we have to find the derivative of this function with respect to x. That is dy over dx. Okay, so before we find derivative, let's multiply the first term and second term, because here we have product of three terms and all the three terms contain variable x. Okay, if I multiply the first two terms, I'll have the product of only two terms which contain variable. So I can use product rule. So if I have the product of three terms which contain variable, it's a bit difficult for me to use the product rule. So first, let's multiply the first term x and the second term, I mean the binomial x positive 1. Okay, let me do it first. Y equals to, so when I distribute this x to this x, it will become x square. When I distribute this x to this 1, it will become positive x times x cube negative 1. So now I have the product of two binomials, and both the binomials contain variable x. Okay, so whenever I have product of two terms and I want to find derivative of that one, I mean where both the terms contain variable, I have to use a product rule. What is product rule? Okay, let's consider the product of two variables u and v. So here both u and v are variables, and I want to find product of this uv, that is uv whole prime. So what I need to do is I have to keep the first term u as it is and get the derivative of the second term, that is v prime. Now I have to get the derivative of the first term, that is u prime. I have to keep the second term as it is, that is v. So this is product rule. So I'm going to apply this product rule in our problem. So for that, I consider the first binomial x square positive x as u and the second binomial x cube negative 1 as v. Okay, so how can we get derivative for this one? So when I find derivative of this y with respect to x, because according to the question, we have to find the derivative of y with respect to x. When I find derivative of this y with respect to x, I'm getting dy over dx. Okay, here, so I'm going to use product rule for this one. So first I have to keep u as it is. That is the first binomial as it is, x square positive x times. I have to get the derivative of the second binomial, that is the x cube negative 1 whole prime. Now let's take positive sign. Now I have to get the derivative of the first term, that is x square positive x whole prime. I have to keep the second term as it is, that is x cube negative 1. Okay, now let's do derivative. Okay, so we get x square positive x times, when I find derivative of this one, so what's the derivative of this x cube? I just have to use the power rule of derivative. What is the power rule of derivative? So let's consider x to the nth power, and I want to find derivative of this one. So what should I do? I have to bring this exponent in front of the variable and subtract 1 from the exponent. This is the power rule of derivative. So x cube is in the form of x to the nth power. So when I find derivative of this one, I have to bring the exponent 3 in front of the variable and subtract 1 from the exponent, then 3 x square negative. The derivative of the constant 1 is 0, positive. Okay, now I have to get the derivative of this x square positive x. When I find the derivative of this x square, the same thing, I have to use a power rule. That is, I have to bring the exponent in front of the variable and subtract 1 from the exponent. If I subtract 1 from this exponent 2, it will just become 1. So whenever the exponent is 1, we will not mention. So we'll simply write it as 2x positive. So the derivative of this x with respect to x is just 1. So whenever I find derivative of a variable with respect to the same variable, it will result 1 times x to the third power negative 1. Okay, now we have dy over dx equals to x square positive x times 3x square negative 0 is 3x square. Then we have, so here we have the product of two binomials, and there is a positive sign over here. Since we have positive sign, we can multiply the two binomials and we can write the result over here. So in case, what if we have a negative sign over here? If I have negative sign over here, first I have to get the result of this product, and then I have to distribute the negative sign over here to the result. But we don't have such a stuff here, because here we have positive. So simply we can multiply the two binomials and we can write the result over here. So for that we can use the FOIL method. That is, first we have to multiply the first terms, outer terms and inner terms and last terms. So first let me multiply the first terms of the two binomials. 2x times x cube will become 2x to the fourth power. When I multiply this 2x and negative 1, it will become negative 2x. And now I multiply the inner terms, that is positive 1 times positive x cube will become positive x cube. 1 times x cube is x cube. Now multiply the last term, positive 1 and negative 1 will become positive times negative will become negative. 1 times 1 is just 1. Okay, now what we can do is we can distribute this 3 x square to the x square and positive x. Okay, let me do it in the next step. Dy over dx equals to, when I distribute this 3x square to this x square, I'm getting 3x to the fourth power. When I distribute this 3x square to this x, it will become 3x to the third power, positive 2 times x to the fourth power, negative 2x, positive x cube, negative 1. Okay, now we have to do simplification. So dy over dx equals to, okay, the degree of this expression over here on the right side is 4 because that is the largest exponent of the variable x. So there are two terms which contain x to the fourth power, this one and this one. So when I combine this 3x to the fourth power and 2x to the fourth power, it will become 5x to the fourth power. And then there are two terms which contain the exponent 3 for x, this one and this one. When I combine this positive 3x cube and positive 1x cube, I'm getting positive 4x cube. Okay, there is only one term with x, so there is negative 2x, and there is only constant term negative 1. So at last we have to write negative 1. So now I got the derivative of the given function. So the derivative of the given function equals to 5 times x to the fourth power positive 4x cube negative 2x negative 1.